On June 17, 2002, astronomers at the Massachusetts Institute of Technology discovered that a small asteroid had flown past the Earth, just 120,000 kilometers away. This shard of rock measured between 50 and 120 meters in diameter and was traveling at some 38,000 kilometers per hour. If it had actually collided with our planet, the disaster would have been simply devastating. The impact of an asteroid on the surface of the Earth is possibly the greatest threat faced by this planet's inhabitants. It is also the most improbable. The violent transformations of the very ground we trod form an important part of the Earth's creative dynamic. A dynamic that long ago generated the conditions for life to emerge. A dynamic which allowed man to appear. A dynamic that is certain to continue its unalterable course. August 26, 1883. The legendary volcano Krakatoa explodes with such fury that the map of the Pacific Ocean will never be the same again. The eruption caused 35-meter-high tidal waves that surged as far as 13,000 kilometers. 36,000 people died. A cloud of ash shrouded the planet for a year. This lake near Chicago was formed over a period of several thousand years. These, on the other hand, in Valdivia, Chile, were created in 2 days, on the 21st and 22nd of May, 1960, during one of the most powerful earthquakes ever recorded. It registered 9.5 on the Richter scale. Its fury moved entire mountains and formed new rivers. Shortly afterwards, a giant tidal wave destroyed everything in its path. Thousands of homes, trees, animals, and human beings. Once again, the Earth received a kind of geological facelift. Such creative violence entails horrible tragedy for living things on this planet. However, at the same time, it generates new ways, new forms of life, new habitats. The Earth, after all, is a dynamic, living thing. The Sahara Desert. One of the most inhospitable places on the planet. Vast plains of sand. Dunes swept by unpredictable winds, ratifying the extreme conditions of its inhabitability. But it wasn't always that way. Once upon a time, these sandy climbs were crisscrossed by raging rivers. The mountains were covered with forests, and a remarkable number of different animals and plants thrived in an essentially perfect environment. This was a dense jungle, teeming with life, but that was 200,000 years ago. Since then, the Earth has carefully redesigned the land and created a wholly unique panorama. Are these catastrophes or manifestations of evolution? Earth destroys and recreates so whimsically. It does so over enormous periods of time, or very quickly, with almost always surprising results and with purely physical mechanisms. Human interpretation of the Earth's behavior is hardly unanimous. Facing those who defy her inexorable destructive rigor are those who think of Mother Earth as a fabulous system, defined in essence by its very evolutionary capacity. That is the basis for the controversial theory of Gaia. Gaia was the name given to a rather romantic theory, one that might seem more poetic than scientific, by the British scientist James Lovelock. His inspiration was Gaia, the oldest goddess known from Greek mythology. Lovelock set forth a kind of metaphor in which everything, air, rivers, oceans, rocks, and living things, were all integral parts of a most perfect harmony that formed one unique entity. Since man appeared on Earth, he has tried to dominate it, tame it. Crops, mines, settlements. They have all changed the face of the planet at unpredictable speed. However, the Earth continues on its evolutionary path, producing great catastrophes that are like battles in which human beings can do nothing. The very ground we walk on continues to be an uncontrollable enigma. Up until now, we have been concerned with creating environments that can protect us against natural threats. We are able to predict in part the behavior of the atmosphere, and we can foresee volcanic activity. There will come a time, probably quite far off, when we can accurately predict seismic movement, though the best we can do today is try to palliate as best we can its effects. The 18th of April, 1906, 5:13 a.m., an intense earthquake rattles the city of San Francisco. It registered 8.4 on the Richter scale, the equivalent of the destructive force of 6 million tons of TNT. In only 47 seconds, the city was essentially razed. The 17th of October, 1989. San Francisco is once again the venue. This time the magnitude is 7.1. "15 seconds were more than enough to cause 27 major fires, destroy hundreds of buildings, and kill 300 people. Every year, several thousand seismic tremors shake the Earth. Most of them occur in uninhabited areas. People are affected by only a few of them. Here at the National Earthquake Institute in Denver, Colorado, seismic data from all over the world is collected and analyzed. The number of tremors capable of producing damage to our cities is in the dozens. Fortunately, only a few cause major catastrophes. The least frequent earthquakes are those registering over 8 on the Richter scale. 1 or 2 may occur on an annual basis, and their consequences are devastating. Predicting them is one of 21st century science's greatest challenges.
It is just so complicated and so many variables that it is almost impossible at the present time to be able to forecast and predict earthquakes. And a lot of money was being spent in the United States, and they thought it would be better spent working on mitigation and trying to build buildings and be able to build these buildings so they will not collapse when the earthquake occurs.
We live on fragile plates that are constantly moving. It's not a coincidence that the east coast of South America and the west coast of Africa look like pieces of a jigsaw puzzle. For many years, it was thought that this was just a whim of nature. Scientists believed that continents were solid, immobile masses. The German Alfred Wegener, with his theory of continental drift, was the first to posit the contrary. That was in 1915. Wegener observed that the geological characteristics of the continents, which were located miles apart, were actually very similar. For example, the Appalachian Mountains in the eastern part of the United States seemed to fit perfectly with the Scottish Highlands. He realized that the rocky strata of the Karoo system in South Africa was remarkably similar to the Santa Catalina Range in Brazil. And he found fossils of tropical plants on the Isle of Spitsbergen near the Arctic Circle. Wegener's intuitive deductions led to hard proof, but unfortunately this inquisitive German scientist would die in 1930 before anyone would recognize the gravity of his discovery. He hadn't managed to uncover the existence of shifting continental plates, a discovery that would not arrive until later. Today, however, we know without a doubt that the continents have been on the move throughout history, and that they are still creeping slowly but surely on, and that they will continue to do so for millions and millions of years in the future, perhaps even after mankind has come and gone. The system underlying the displacement of these enormous supercontinental platforms was set forth in the 1960s in the theory of tectonic plates.
The Earth's lithosphere, that is, the rigid layer that makes up the planet's surface, is not continuous. It is fragmented and divided into various units. These are the so-called tectonic plates. There are 7 large tectonic plates, then a number of medium-sized ones, and a dozen or so smaller plates of lesser dimensions have also been identified. These plates do not necessarily just consist of continental crust or even oceanic crust. There are plates whose limits include oceanic crust, or rather some of the oceanic lithosphere, and the continental lithosphere. This means that a given plate might be made up of, say, the North American continent and also part of the Atlantic or Pacific Ocean.
$250 million years ago, the plates comprising Earth's lithosphere formed one enormous continent, known as Pangaea, or Gondwanaland. By studying the displacement of land masses since then, the tectonic plates theory allows us to foresee future changes in the Earth's physiognomy. The Mediterranean Sea, for example, is expected to narrow until Africa and Europe are one. Africa will divide into 2 different continents. An ocean will separate them. Australia will drift ever closer to Asia. Tectonic plates are closely related to seismic activity on Earth. In fact, the positioning of the continental platforms determine where earthquakes are most likely to occur. An area known as the Circum-Pacific Circuit, for example, is a source of 80% of all our planet's seismic activity. The eastern coasts of the Japanese islands are particularly vulnerable. Catastrophes such as the earthquakes in Tokyo in 1923 or Kobe in 1995 form part of the indelible collective memory of the Japanese nation. Seismic activity around Kobe, for example, which is some 500 kilometers southeast of Tokyo, is subject to maximum scientific analysis. The region has been mapped millimeter by millimeter and is home to the most sophisticated measuring equipment in the world. Scientists believed that they would be able to detect any threatening seismic activity sufficiently early so as to evacuate endangered population centers. But they were wrong. On the 18th of January, 1995, a prestigious convention was held that brought together leading Japanese and American seismologists. While they debated the ways they might assuage the effects of destructive seismic activity, a disaster occurred. An earthquake measuring 7 on the Richter scale shook the city like a toy. The catastrophe left 6,000 people dead. It destroyed buildings, ripped bridges apart, turned highways into crumpled chaos. The elevated bullet train, a symbol of advanced Japanese engineering, was ripped apart in no less than 9 places, despite the fact that it had been designed to withstand seismic shocks of even greater magnitude. The attendees to that conference certainly never imagined that they would be so disgraced as to have to work in such horrifically authentic conditions.
We knew there was activity. Internal displacements occurring in Kobe and in the surrounding areas. But no system or person could have foreseen that that was going to happen on that day, at that moment in 1995. Because in Japan, there's always a lot of seismic activity. And it is very difficult to determine exactly which particular manifestation is going to cause an earthquake, especially like the one that occurred that day in Kobe.
On February 4, 1975, a group of Chinese researchers alerted the people of Haicheng, in the northeastern part of China, of the imminent possibility of a major earthquake. Exactly as they had predicted, a tremor measuring 7.3 razed the city just a few hours later. Fortunately, the authorities had been given enough time to evacuate most of the populace. The catastrophe killed 1,328 people, a relatively small percentage of the people living in that densely populated area. The system had worked.
Yes, they did predict one earthquake. And the way that they predicted that earthquake, they instrumented the area with many instruments around the area that they thought the earthquake would occur. And during the time that they had this area instrumented, they could see many small earthquakes, and these earthquakes were increasing by some number or so many tenths each day, each week. And they projected and said, if this would continue, we would have this large earthquake on this particular date. And they were able to say that this earthquake was going to be there because of the way the smaller earthquakes were increasing, and therefore they could say on this date, at this rate, we'll have the big earthquake. And they were able to predict that earthquake, but that was mostly precursor activity in the area.
Since then, it has not been possible to predict any other earthquakes with the same precision. Countries such as the United States and Japan, which are particularly at risk, dedicate significant resources to studying seismological activity. Nevertheless, even though we could anticipate the occurrence of a deadly earthquake, the possibilities of mobilizing endangered population centers would still be relatively limited. Even if we are someday able to predict the fury of the forces of nature unleashed by the Earth in its ongoing mission of planetary transformation, it may be practically impossible to actually control them. Between 9 and 10 o'clock at night, the Earth opened up near Timanfaya, about 2 leagues from Yaitha. On the first night, an enormous mountain rose up out of the ground, and from its highest point, flames shot up into the sky and continued to do so for 19 days. Those are the words of an eyewitness describing the volcanic eruptions that took place on the island of Lanzarote in the Canary Islands in the 18th century. They started on the 1st of September, 1730, and lasted until the 16th of April, 1736, over 5 years. More than a quarter of the island was affected by the disaster. The Canary Islands are volcanic in nature. Millions of years ago, volcanoes formed low-lying mountains in the Atlantic Ocean off the coast of northern Africa. They broke the surface of the water and, according to songs and popular lore, reached far into the sky. Over the course of tens of millions of years, volcanic activity has shaped these islands and formed these rather fantastic and somehow disturbing landscapes. The most recent volcanic event in the Canaries occurred in late 1971. It lasted 24 days. Many years have passed, but this area continues to be one of the most observed on the planet. All the volcanic activity in the Canary Islands is controlled from this center, the Geodynamic Laboratory in Lanzarote, one of the best equipped in the world.
Predicting a volcanic eruption precisely when it occurs is practically the obligation of those of us who study volcanoes. A volcano, normally, or rather an eruption of the surface, entails enough premonitory phenomena to alert us to any process that might occur. Our problem is knowing how to identify said phenomena, which range from earthquakes or very characteristic tremors to equally characteristic terrain formations, or even changes in hyperthermal conditions in the area where an eruption might occur, or modifications in the release of volcanic gases, which are continuously spewing out of the fumaroles.
Today, scientists have sophisticated equipment that allows them to detect volcanic eruptions months before they occur. To do so, the volcano must be under observation around the clock. Nevertheless, of the 2,000 active volcanoes in the world today, only 100 or so are subject to this kind of analysis. We tend to think of volcanoes as heralds of death and destruction, but actually few other occurrences in nature prove even remotely as beneficial. Ash from volcanic eruptions fertilizes humid areas. Thermal waters are of great use in a wide range of therapeutic treatments. In fact, the intense volcanic activity that took place in the first stages of the Earth's formation gave rise to the atmosphere and the concomitant conditions required for life. Just like continental plates, oceans, volcanoes, and the atmosphere, living things also form an essential part of the machinery of planet Earth. We breathe the oxygen given off by plants. We eat products provided by specific species. We eliminate certain substances that are then used by other species as sustenance. We all need each other to survive. As humans, we add a few articles to the list of demands that the Earth takes the responsibility of providing. We find compounds in the forests and oceans to make medicines, to build houses, or make fibers with which we clothe ourselves. In just one day's time, mankind uses some 40,000 different species of living beings to satisfy his needs, and many, many more to satisfy less vital desires. It should come as no surprise, then, that human activity, particularly since about 300 years ago, is the prime cause of the deterioration of the Earth's biodiversity. In short, we're abettors of a new kind of catastrophe. The disappearance of species is something that is inherent in the development of life on Earth. From the time the very first living organism appeared, some 4 billion years ago, over 50 billion different kinds of animals and plants have inhabited our planet. Some of them disappeared as a consequence of natural disasters or the very process of natural selection. Others evolved and came to form part of the biodiversity we see around us today. There are no precise studies, however, on the quantity of animal and plant species that currently live on Earth. While some scientists contend that there are more than 30 million, the fact remains that we have only cataloged approximately 1,750,000 of them.
We don't know how many species there are on Earth, so it is very difficult to know how many become extinct. If you don't even know how many there are, you can't know how many you're losing, because what you don't know you're losing, well, you can't count on that as an asset. There are gross estimates that postulate that we're losing, say, at least somewhere between 1,000 or 2,000 and 5,000 species every year, and at most 50 or 60,000. Since our society requires precise, round numbers, accurate figures, the scientific community tends to use a figure of 27,000 species, again, just a gross estimate. Now, these 27,000 species that become extinct every year would mean that in 1,000 years we would lose 27 million species. That is to say that in just 1,000 years, which is a very short time in a geological sense, practically all of the life forms on Earth today would disappear. The process began some 150,000 years ago, when the mechanisms of natural evolution gave rise to the appearance of early Homo sapiens.
The nomadic hunters of these primitive communities were the cause of the extinction of certain bird species and large mammals. Between 6,000 and 11,000 years ago, our ancestors learned how to grow crops and husband animals. This incipient agricultural experience was the cause of the first major alterations to the environment. With the arrival of the first inhabitants of North and South America, the processes leading to the extinction of certain species appeared. Large animals, those with plenty of protein-rich meat, were the first to disappear. In barely a few hundred years, numerous mammal species, both in North and South America, disappeared forever. Human activity over the past few centuries has caused more destructive upheaval on planet Earth than all our activity during the hundreds of thousands of years before that. Colonial expansion by European countries, for example, caused successive transformations of the land itself all over the planet. Since then, we steadily continued to transform jungles and forests into industrial zones. We continue to overexploit our agricultural resources, and we force certain species of both animals and plants to live in environments that are not truly theirs. The main causes of the deterioration of the Earth's biodiversity are still very much at work today, albeit with a few differences. The first Homo sapiens, from whom all human beings have descended, were very few in number. Today, there are over 6 billion of us. Every year, we need to clear 142,000 square kilometers of tropical rainforest. That's more or less akin to a professional soccer field per second. Since prehistoric times, we have reduced the Earth's ecosystems by 50%. We cut down trees for wood and to clear pasture land. We build dams, railroads, and highways. And when we do, we destroy the ecosystems that support animal and plant species. We have even managed to alter the migratory routes of birds. The destruction of habitat is one of the main causes of the deterioration of the Earth's biodiversity. When we destroy a certain species' vital space, we eliminate the resources they need to live. These species have only two choices: adapt to new surroundings or perish. The equilibrium of life on Earth is more fragile and complicated than mankind can possibly know at this date. The slightest alteration in an ecosystem, such as an involuntary introduction of a new species, can unleash a process of destabilization whose consequences could be nothing short of a silent, rapid holocaust. In these idyllic climes along the French Riviera, we might be witnessing one of the greatest environmental catastrophes in recent history. Its cause is a kind of alga, the Caulerpa toxifolia, also known as killer kelp. This seemingly inoffensive plant thrives in the Caribbean Sea. It arrived here in 1984 due to an error by the operators of the Monte Carlo Aquarium. The effects were quickly apparent. Killer kelp grows at a rate of about a hectare, nearly 2.5 acres, in 5 years' time. Basically, it destroys every other kind of aquatic plant in its path. Animal species are naturally affected as well. This type of alga is of no use to them as a food source. Up until 1991, its eradication was possible, but since then it has spread beyond control. Now the only solution is to try and stop killer kelp from reproducing. Each year, many animal and plant varieties disappear because of the abuse they suffer at the hands of mankind. For quite some time now, the dizzying evolution of human beings has been generating a progressive increase in the perilous situations threatening the Earth's biodiversity. In the last century and a half, the population of the world has increased by some 5 billion people. The growth of our species is becoming more and more incompatible with the development of the rest of the living beings on the planet. But we have no other choice than to share the 510 million square kilometers in which we all live. The human population imposes its demographic expansion with a view to possess the environment. The manifestation of this is an alteration of natural spaces and the excessive exploitation of resources. The presence of our species challenges the very development of a larger dynamic that is measured in millions of years and which is subject to cycles we don't even understand yet. The Earth's climate changes. This is another dynamic, or mutation, that is inherent to a living planet. The history of the past 1 million years is replete with enormous contrasts regarding atmospheric conditions, lengthy ice ages interspersed with warm transitional periods. 10,000 years ago, the average global temperature was 4 or 5 degrees Celsius less than it is now. Since then, the climate has oscillated between extremes until the last quarter century or so, when a trend characterized by the highest temperatures ever recorded began. The Earth's climate is a complex system in which the air of our atmosphere interacts with the planet's surface. The oceans, the ice caps, the ground itself, and all living organisms play determining roles in its configuration. However, now it's necessary to add a new agent of influence: mankind. Over the past 20 years or so, scientists have observed that due to industrial activity, the Earth's temperature is increasing faster than it should be.
The temperature changes to occur around the globe at about 0.2 to 0.3 degrees Celsius per decade. So within 30 years' time, it is likely to be about a centigrade warmer than it is now, or a degree Celsius warmer than it is now. And that's a very rapid rate of change, seeing that the climate system of the last 140 years has risen by just under a degree Celsius. We're also seeing rises in sea levels. As the temperature warms up, the oceans warm up and they expand. So sea levels are rising, and we expect the rate of change in sea levels to be in the region of about 4 to 10 centimetres per decade. So again, a fairly alarming rate of rise.
These coral reefs provide the principal source of sustenance for over 60 kinds of fish commonly consumed by human beings. But that may not be the case just a couple of decades from now if current predictions on global warming prove accurate. It will be the end of the line for those species, 500 million years after they first appeared. If we continue to spew toxic gases into the atmosphere, the so-called greenhouse effect will cause temperatures to rise by between 1 and 3 degrees Celsius over the next few years. The ice in the polar regions will melt, and the level of the oceans and seas will rise by as much as 2 meters. Some countries, such as Holland, will be reduced in size by half, while many islands will simply disappear under the waves. The animals and plants living in such places will probably cease to exist. At the same time, increasing temperatures will invariably alter tolerance parameters for a host of species. Some will seek out new habitats. Others, a vast majority, will be unable to adapt and will disappear forever. A true catastrophe by any measure. comparable to the one that occurred 65 million years ago when the dinosaurs were wiped off the face of the Earth, a catastrophe that this time will be called mankind.
If we cannot stabilize population and if we cannot stabilize climate, there's not an ecosystem on Earth we can save. Everything will change. We can set land aside and call them parks or wildlife reserves and build fences around them, but if climate changes, the ecosystem will change. So there's a long list of stresses that are developing in the relationship between the global economy and the Earth's ecosystem. They include desertification, deforestation, overgrazing, overplowing, soil erosion, rising CO2 levels, rising temperature, more destructive storms, falling water tables, rivers running dry, disappearing species, dying coral reefs. There's a long list of stresses now developing as the global economy keeps expanding, but the Earth's ecosystem remains the same.
Each time an animal or plant species disappears, we lose the possibility of curing diseases like cancer or AIDS. Over 3/4 of the medicines prescribed in industrialized countries are made with natural compounds. But that's not all. Plants maintain the atmospheric balance necessary for life on Earth. Insects pollinate flowers. Birds protect our crops. Aquatic animals purify the water. Bacteria regenerate the fertility of the soil. All living beings are unique and unrepeatable components of this planet, which in turn is a complex mechanism where everything is carefully connected. Human beings have only been around for approximately 150,000 years. Scientists believe species have lifespans of between 1 and 10 million years. In theory, we have a long and unimaginable future ahead of us to learn how to preserve the Earth's biodiversity of which we form a part. A long future to lessen the risks caused by the violent geological evolution of our planet. But sometime along the path of that future, it's also possible that we may have to face a threat that comes from somewhere far, far away. This threat is known as NEOS 2, or Near-Earth Object, and there is a great deal of evidence suggesting that the dinosaurs became extinct when an asteroid of similar characteristics sliced through the atmosphere and slammed into the Earth's surface. That occurred some 65 million years ago, and it was only about 10 kilometers in diameter. However, it has been calculated that its destructive force was 10 billion times that of the atomic bombs dropped on Hiroshima and Nagasaki in 1945. The fires the collision caused devastated the entire southern part of what is now North America, the Indian subcontinent, and the greater part of the Earth's equatorial belt. A vast number of species were doomed to extinction. Along with the dinosaurs, thousands of plant and animal species, half of those in existence at the time, were simply obliterated. The Earth took 12 million years to re-establish its ecosystems. The event changed the entire face of our planet. While the dinosaurs disappeared, at the same time there was a veritable explosion of other forms of life, principally mammals, which had until then been forced to occupy only a small corner of the Earth's overall ecosystem. Human beings, like so many other components of nature, are the result of that horrible destruction. The odds of a NEO colliding with the Earth have been estimated at 1 every 1,000 years. Over the past few decades, scientists have come to the conclusion that catastrophic threats coming from outer space could very possibly be much more destructive than those generated on the planet itself. We know that hundreds of NEOs cross the Earth's orbital path. Any one of them could, theoretically, smash into the planet and provoke a disaster that would be unprecedented in the history of mankind. Experts watch the skies closely and classify NEOs according to their dimensions. There are NEOs that are over 1 kilometer in diameter. A body of that size would produce damage on a global scale, including the alteration of the atmosphere and major climate change. If a NEO measuring 1 kilometer in diameter did in fact collide with the Earth, human beings would be very hard-pressed to survive. The impact of smaller-sized NEOs would provoke local catastrophes, but would not cause the extinction of species. Some scientists believe that a NEO might hit the Earth sometime around the 31st of January or the 1st of February 2019. Obviously, the calculations are not 100% certain, but the extremely sophisticated research programs in use are working around the clock in an effort to avoid this type of catastrophe. One of these projects is called the Don Quixote mission. It was designed by the European Space Agency and is manned for the most part by experts from Spain. The project is studying the real possibility of changing the trajectory of a threatening body from outer space through the use of specially made projectiles. The system is expected to be operational by 2012. The history of the Earth clearly shows that no natural disaster originating on the planet per se could possibly be as destructive as the impact of an asteroid from outer space. It's also very possible that we might not be able to defend ourselves against the effects of a NEO. In fact, the human race may one day become extinct. In such a worst-case scenario, the Earth would once again invest millions of years to re-establish the course of life. Maybe one day, paleologists from some future intelligent civilization might find evidence of our existence through the traces we leave behind. What kind of beings might these future people be? What would the plants and animals they live with be like? What creative marvels will Mother Earth have come up with by then? Until a disaster of such proportions occurs, the greatest share of responsibility for life on our planet falls squarely on the shoulders of mankind. Maybe one day we might be able to control the causes of the processes that seem to be driving us straight into a future marked by major climatic changes. Perhaps we might someday be able to lessen the alarming frequency with which both plant and animal species are disappearing. In both cases, the destiny of our world would once again depend on the whims of nature. The Earth was born along with the Sun some 4.6 billion years ago, and it will die along with the Sun after a more or less similar period, although most likely we won't be here to see it. Chaos or equilibrium. Our planet stays a steady existential course, a course where cataclysm plays a key role as a kind of catalyst of Mother Earth's very existence, and as such, of ours.